Good morning, students. Welcome to the course CSE 460 VLSI Design. I am your course instructor, Farzana Yeasmin, and I'm from Department of Electrical and Electronic Engineering, University of Dhaka. So today we are going to discuss about overview of VLSI. Let's move to the course material first. As you can see, our course is divided into two parts, theory and lab. For the theory part, you need to follow three materials. First of all, a book, then lecture slides, and then series of YouTube videos. Okay, so for the laboratory part, you need to install or you need to use the CAD software. By using this software, we are going to draw some cadence schematic and layout, which will be industry standard, and we are going to follow some online tutorials. Okay. So, as I already mentioned, this is a overview or introductory class. So we are not going to going deep any topics. We're just know the surface level knowledge of what is VLSI or overview of VLSI is. So first you can see there are many kinds of, okay, as if my use my pen here, then you can see some abbreviation SSI, MSI, LSI, VLSI and ULSI. So you can see we are interested in this part VLSI. Okay. So now what is the difference between the name? Okay. So you can see the number of transistors and the number of logic gates are varied from one kind of integration level to another. As you can see, the number of transistors and number of logic gates are successively increasing with the years. And for the increasing number of transistors and the number of logic gates, the integration levels name is also changed. Okay, so here, as you can see, for the first one is SSI or small scale integration. Here, the number of transistors and the number of logic gates is not so high, or we can say very low. That there can be 1 to 10 transistors and 1 to 12 logic gates. Okay, so then come to the medium scale integration, large scale integration, and now we are in the very large scale integration. And here the number of transistors are used 20,000 to 1 lakh, and the number of logic gates are used 10,000 to 99,999. Okay, so now you may have a question about what are the logic gates. Okay, so let me clear you the question with the logic gates. Okay, so the logic gates you can see is none other than the OR gate, the AND gate, the NOR, the NAND, which you have already studied in your intermediate ICT course. Okay, so I can expect you have a minimum knowledge about the logic gates uh, and or not, and so on. Okay, now moving to the next slide, we can see here is a VLSI design or VLSI chip funnel. You can see the headline is complexity and design. So you cannot say it is a very easy design, rather it is a really complex design. And for the design purpose, you need to have some kind of tools or some kind of supply of materials, and which are them. Okay, so first of all, you need to have the idea. Now, what is the idea about? The idea is about what kind of chip or what kind of output you are expecting from the chip. Okay, so then the sand. Now you may be curious the why we are using the sand. Okay, but so the sand is, actually silicon dioxide. Okay, what is it? Silicon dioxide. And you are going to read about the details of production silicon from the silicon dioxide. And our chip are made of silicon, and the silicon we are used in a chip are made of silicon dioxide. Okay, so silicon dioxide or sand is a very crucial material in this system. Then we need to use our software CAD. Why we are using software? Because we are not going to manufacture it firstly hard in our laboratory before using cat. Okay, as there may be we can make some error, we can make some mistakes while producing the chip. So first of all, we need to draw a schematic, we need to draw a physical diagram of the chip. Then when it comes successfully, then we are going to produce this in our lab. For and also, engineers are the persons who are doing the job very carefully. So they are uh, they play a very important role in this segment. And then marketing, you need to market, you need to do very good quality of marketing of your product. Without marketing, you cannot introduce your product in the market as okay. So then you can see we need some kind of currencies, which is a very important part. Then moving to the next slide, you can see this is a design hierarchy. Now, what is hierarchy? Hierarchy means particularly the chain of command. Okay, what is the chain of command? It's depends on an organizational performance. Okay, so in this part you can see a top, there are two keyword, top design level and the bottom design level. Now, what is this? What are they? In the top design level, the designer specifies the system, or they develop the initial concept. They develop the initial concept about how proper functional chip can be made in the laboratory. Okay. And after performing the system specification step, they are going to do the abstract high level model VHDL or Verilog HDL. Okay. And then this step is also known as system design and verification. Then comes the logic synthesis. In this part, you are going to do some kind of logic synthesis like and or not, and so on. Okay, so you can see, and then move to the circuit design. If you when you are going to design the logic perfectly, then you are moving to the circuit design, and then the physical design. And this is called the bottom design level. In this step, the chip is finally produced for the finally produced for going to the market. Then the manufacturing process, and after performing all these steps, you can get a finished VLSI chip. Okay. Then you can see a simple design flow. Now, what is the design flow? The design flow is about how a chip is made in the lab in a semiconductor industry with very with the perfect specification and the buyer's demand. You can see there is a flow chart I presented in my slide, and you need to memorize it and it is very important for the exam also. Okay, so as it is a introductory class, so I'm not going to discuss details. And if you have any question, you can ask me.